Hello everyone, let us discuss some more example based on Fourier series of even and odd function having the interval minus pi comma pi. This is second example on that. Obtain the Fourier series in minus pi comma pi for f of x is equal to x cos x. Solution: we know that the Fourier series of f of x having the period 2 pi is given by f of x is equal to a naught by 2. This is a standard result, you already know this one. N is equal to 1 to infinity an cos nx plus summation n running from 1 to infinity bn sin nx. Name this is equation 1. Now check whether the given function is even or odd. For that we shall check f of x is equal to x cos x is even or odd. For that f of minus x is equal to minus cos of minus x, which is equal to minus cos x, which is equal to minus f of x. Therefore we get f of x is equal to minus f of x. Therefore hence the function f of x is equal to x cos x is odd. We know that when the function is odd, the value of an and a naught is 0. Here just we have to find the value of bn. Consequently a naught is equal to 0, an is equal to 0. Then we know that bn is equal to 2 by pi integration from 0 to pi f of x sin nx dx, which is equal to 2 by pi integration from 0 to pi f of x is x cos x into sin nx dx. Now see this cos x sin nx. For this we have to use the cos a into cos b formula. Name this is equation 2. bn is equal to x cos x into sin nx dx, or not this one, write it as bn divided by 2 by pi integration from 0 to pi x sin nx into cos x dx. Name this is equation 2 and use the result. We know that sin a into cos b is equal to 1 by 2 into sin a plus b plus sin a minus b. Use this result for this integral. We get bn is equal to 2 by pi integration from 0 to pi x into 1 by 2. This is a sine a plus b. A is nx, b is x. Therefore nx plus x plus sine nx minus x dx. Here 1 by 2 is a constant. It will be 2 divided by 2 pi integration from 0 to pi x into sine. In these two terms x is common, n plus 1x plus sine n minus 1 x dx, which is equal to 2 get cancelled, it is 1 by pi. Now multiply this x to both the terms, not this one, both the terms, and separate the integral. We get integration from 0 to pi x into sine n plus 1x dx plus limits from 0 to pi x into sine n minus 1x dx. Now to find this integral we have to apply the Bernoulli's rule. Applying Bernoulli's rule to each of the integrals, then bn is equal to 1 by pi. It is as it is. For the first integral, this is x as it is. Integration of sine n plus 1 is minus cos of n plus 1 x divided by n plus 1, and this is minus differentiation of x is 1. Then again integration of this one is minus sine n plus 1 x divided by n plus 1 into n plus 1, it is n plus 1 whole square. First one is over, limits from 0 to pi. For the second one we will write here, then it is plus of x as it is. Integration of sine n minus 1 is minus cos n minus 1 into x divided by n minus 1 minus, this is 1 minus sine n minus 1 x divided by n plus n minus 1 whole square, limits from 0 to pi. Now apply the limits, which is equal to, before that I will write this once again with simplification. This is a minus x into cos n plus 1x divided by n plus 1 minus into minus plus sine n plus 1 x divided by n plus 1 whole square, limits from 0 to pi. Next this is minus, this is minus, it will be minus x into cos n minus 1x divided by n minus 1. This is, I will write this plus and this will be minus. It's minus into minus plus sine n minus 1x divided by n minus 1 whole square, limits from 0 to pi. Now I will apply the limits to a particular terms. This is what Bn. On applying the limits, Bn is equal to 1 by pi as it is. Apply first term, upper limit and lower limit. This is 1 divided by n plus 1 is constant, minus pi cos n plus 1 pi minus upper limit minus of 0 it is. This is for first one. Then plus 1 divided by n plus 1 whole square constant. Next it will be sine n plus 1 pi minus 0, sine 0 is 0. This is for first term, it is over. Next one plus minus pi cos of n minus 1 pi divided by n minus 1. Upper limit is over, minus lower limit, x to 0 means it is 0. Then for the last term plus 1 by 1 minus n minus 1 whole square is constant. First applying upper limit, sine n minus 1 pi minus sine 0 is 0. These are the terms on applying the limits. After that simplify this one, 1 by pi, this is minus pi divided by n plus 1. We know that cos pi value is minus 1. Here we have n plus 1, therefore it is minus 1 raised to n plus 1. Then this is 0 because cos pi value is 0, sin pi value is 0. This term will be 0. This is, here we have my negative sign, minus pi minus 1 raised to n minus 1 divided by n minus 1, and this is again, this is 0. Now Bn is equal to, take minus negative sign and pi common in this two term, we get minus pi by pi. This is minus 1 raised to n plus 1 divided by n plus 1 minus, sorry it is plus because I am taking negative sign common, divided by n minus 1. then it will be bn is equal to pi get cancelled, minus of minus 1 raised to n plus 1 divided by n plus 1 plus minus 1 raised to minus 1 raised to n minus 1 divided by n minus 1. Now take minus 1 raised to n common, minus of minus 1 raised to n, it is common, it will be 1 raised to 1 divided by n plus 1 plus minus 1 raised to minus 1 divided by n minus 1. bn is equal to, multiply this negative sign to this one, minus 1 raised to minus 1 means it is 1 divided by minus 1, it will be minus 1 raised to n 1 divided by n plus 1 plus 1, it is minus into minus plus, it will be minus 1 raised to minus 1 means we have to write it as 1 divided by minus 1 raised to minus 1 raised to 1, therefore it is 1 divided by minus 1 divided by n minus 1 only, therefore bn is equal to minus 1 raised to n 1 divided by n plus 1 plus 1 divided by n minus 1. Now I will take the LCM to this term. On taking LCM, bn is equal to minus 1 raised to n minus 1 plus n plus 1 divided by n square plus s square n square minus 1, because a square minus b square is a plus b into a minus b. On using this result, the denominator term is n square minus 1, which is equal to 2n minus 1 plus 1 get cancelled, 2n into minus 1 raised to n divided by n square minus 1. See this result, bn is equal to this one. Here for odd function, an is equal to bn is equal to 0, a naught is equal to 0, bn must be not equal to 0. When we substitute n as a 1, we get this is 0, denominator anything by 0 is infinity, so that here it is, the condition is n must be not equal to 1. Here n must be not equal to 1, we shall have to find bn when n is equal to 1. For that we shall now find bn when n is equal to 1, that is to find b1. For that, now let us consider bn as given by equation 2. We have equation 2. From that, consider bn is equal to 2 by pi integration from 0 to pi x sin x nx into cos x dx. Putting n is equal to 1, we get b1 is equal to 2 by pi integration from 0 to pi sin 1x is x into sin x into cos x dx. To solve this integral, we know that sin x into cos x is equal to sin 2x. Here we have simply sin x into cos x, therefore sin x into cos x is equal to sin 2x divided by 2. Therefore Bn will be b1 is equal to 2 divided by pi integration from 0 to pi x as it is sin 2x divided by 2 into dx. Now 1 by 2 is constant. It will be 1 by pi into 0 to pi x sin 2x into dx. Now apply the Bernoulli's rule. We have b1 is equal to 1 by pi as it is, x as it is, differentiation integration of sin 2x is cos minus cos 2x divided by 2 minus 1 into minus sin 2x divided by 2 into 2 limits from 0 to pi, which is equal to 1 by 2 into minus x into cos 2x divided by 2. This is plus sin 2x divided by 4 limits from 0 to pi. Apply the limits. 1 by 2 into not 1 by 2, 1 by pi, it is 1 by pi. Now in this 2 term, otherwise keep as it is and apply the limits. For the first one, this is 1 by 2 as it is, applying upper limit pi cos 2 pi minus 0 plus 1 by 4 sin 2 pi minus sin 0 is 0, which is equal to 1 by pi. It will be minus pi cos 2 pi value is 1 into 1 divided by 2. This is sin 2 pi value is sin pi is 0, sin 2 pi value is also 0, therefore it is 0. Then pi get cancelled, remaining is only 1 by 2. b1 value is minus 1 divided by 2. Next is we shall write equation 1 in the form f of x is equal to a0 by 2 plus summation n running from 1 to infinity an cos nx plus b1 sin x plus summation n running from n is equal to 2 to infinity bn sin n x. On substituting the Fourier series will be f of x is equal to x into cos x is equal to minus 1 by 2 into sin x, because a0 and an value is 0, therefore minus 1 by 2 into sin x plus summation n running from 2 to infinity bn is 2n into 1 minus 1 raised to n divided by n square minus 1 into sin n x is the required Fourier series for the given function. Like that you have to solve the given function.